Hello everyone. This video is on the Knewton Alta assignment for section 6.6 called Dividing Polynomials by a Monomial. In this video, I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the structure should be similar, so I'm hoping that watching me do these here helps you out in some way when you work on the assignment on your own. Alright, on the assignment page you should be seeing the title, the mastery bar telling you how far along you've gotten, and the objectives. And it looks like there's only the one objective for this assignment. And then under the current objective there should be a question related to that objective, and at the bottom of every question you should see a feedback button with some feedback where you can send feedback to Knewton if you wish. Pardon me. Alright, and you will not have this instructor cheat button. Alright, this is for instructors only. You will have the more instruction button if you're ever struggling with a topic or a particular question. Click on this and you'll be taken to a page with some reading or videos to study, and you'll be given questions on those related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so as I mentioned, there's only the one objective here. It's divide a polynomial by a monomial. And the key to this is just reversing adding fractions. Remember, when you add two fractions, say a over c plus b over c, remember the only way you can add two fractions is if they have the same denominator. And if they have the same denominator, that denominator will be the denominator of their sum, and you just combine the numerators. Well, all we're doing here today in this video is going this direction. I'll have a polynomial with multiple terms in the numerator divided by some expression, divided by a monomial. And you just split them up. You just write this one fraction as a sum of multiple fractions with the same denominator. That monomial will be in every single denominator. And you're going to just take every term in the numerator divided by the monomial in the denominator. It's really going to be that simple. And then you of course divide and simplify each of these individual fractions. And you saw in section 6.5 how to divide monomials and use the quotient properties of exponents, so I'm not going to go into all those. I'm just going to do it. So my first example, my first question is, they're asking us to find the quotient, right? Divide. When you see the word quotient, you should think division. Right? Of this polynomial here, it's a trinomial, 3 terms, right? Divided by this monomial. And again, the division symbol, the obelisk symbol, you can write as a fraction bar. And of course, simplify your answer. Alright, so the question we're given first is this. We have in the numerator, the dividend, right, is 10c to the 6th plus, right, and then the second term is 6c to the 5th, and then plus negative 24c is the third term. Right, there's a trinomial in the numerator, right, or as the dividend. And then again, the division symbol can be turned into a big fraction bar. This is divided by. And the denominator is just a monomial, just negative 1c to the 4th. All right, so as I was saying up here, if the numerator has multiple terms, like this has 3 terms, we're just going to split it up into the sum of 3 fractions, where each term in the numerator is divided by the monomial, the term in the expression in the denominator. So this is equivalent to 10c to the 6th divided by negative c to the 4th plus 6c to the fifth, the next term, divided by the denominator, divided by negative c to the fourth, plus, and then the final term in the numerator, negative 24c, divided by the monomial in the denominator, negative c to the fourth. And then of course we just divide each of these pairs of monomials here, simplify each of these. And again, I'm assuming you went through section 6.5 or saw my video there. So I'm just going to say what these are, right? So 10c to the sixth divided by negative c to the fourth would be negative 10. Right, 10 divided by negative 1, and then c to the sixth divided by c to the fourth will end up being c squared, right, using a quotient property of exponents. Then we have plus, 6 divided by negative 1 is negative 6. C to the fifth over c to the fourth is c to the first, so then we have negative 6c for the next term. And then the last fraction, the last quotient here, we have negative 24 divided by negative 1. They'll still be positive, so positive. And then 24 over 1 is just 24, so I'll have 24 in the numerator. And then c divided by c to the fourth would be c to the negative third, but that's 1 over c to the third, right? There'd still be 3 factors of c in the denominator after you cancel one of them. So the last term, the last fraction, the last quotient is 24 divided by c cubed. And this is what they want. This is as simple as all those quotients, all those fractions get. All right, so writing in here in the answer box, negative 10 c to the second minus 6 c to the first, or just minus 6c, and then that last fraction plus 24 divided by c cubed. Right? And there's the result of dividing the trinomial by this monomial. Right, all simplified. All right, and then after you submit an answer, it should tell you if you're right or wrong, and then give you some sort of answer explanation. Please read through the answer explanations, right, just to make sure you can understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, and then every single one of these should be similar to this. You're dividing a polynomial by a monomial. So here we go again, right? Another one where the numerator is a trinomial, right? Has a 3-term polynomial divided by a monomial. And we're just going to take each term of the numerator and divide it by the monomial in the denominator. Write this as a sum of 3 fractions. So yeah, so the numerator is 108 m to the sixth, that's the first term, plus 81 m to the fifth, there's the second term, and then plus negative 324 m, right? That negative 324 m is the third term of the numerator, of the dividend. And the divisor, or the denominator, is a monomial, 9m to the fourth. And like I was saying on the previous page, right, it's the same setup every time here. Multiple terms in the numerator, each one of them gets divided by this monomial. So I can write this as the sum of 3 fractions, where each term in the numerator is divided by the denominator. So this is 108 m to the sixth divided by 9m to the fourth, plus 81 m to the fifth divided by 9m to the fourth. And then, technically you can write plus again, and then negative 324m divided by 9m to the fourth. Okay, or I could have just made that a minus, right, because plus a negative is just subtraction. And then we go through and simplify each of these. Now 108 divided by 9 would be 12. And then m to the sixth over m to the fourth, using the quotient property for exponents, would be m squared. So 12m squared is what the first fraction reduces to. Plus, and then 9m, right? 81 divided by 9 is 9. M to the fifth divided by m to the fourth is m. Plus 9m for the second fraction. And then minus And then 324 divided by 9, let's see, that would be 36, right? 9 times 36 would be 270 plus 54, 324. Yeah, so that's minus 36. But m over m to the fourth, you see how the denominator has a higher power, so there's going to be some factors left in the denominator. And then one of the m's will cancel, and I'm left with m cubed in the denominator, and this is it. Right? This is as simple. None of these terms are like terms. You can't add any of these together. That's as simple as it's getting for each of those fractions. And that's what I'm typing. So first term, 12m squared, plus second term was 9m, and then minus 36 over m cubed, simplifying that last fraction. And that should be good. Excellent. Alright. Again, more of the same. All four problems I'm getting should be similar, or however many problems you're getting. Alright, so again, I'll write this out, but I'm just going to write out the three fractions. So far the examples we've seen have had a trinomial as the numerator every time. That's not always going to happen. There might just be two terms. So then you'd write a sum of two fractions, or there might be four terms, and then you would write a sum of four fractions. But just know that every term in the numerator gets divided by the denominator in those fractions. Alright. So I'm just going to write the split. I'm going to write the sum of the three fractions. The first term in the numerator was 90 x to the fifth y to the sixth, and that's going to be divided by the denominator, which is the monomial negative 9x. Plus the next term in the numerator was negative 108 x squared y cubed, and again this is being divided by the monomial, the denominator, negative 9x. Plus, and then the final term in the numerator was negative 126 negative 126x divided by that same denominator, negative 9x. And then we simplify each of these. First one, the coefficient would be negative 10, and then x to the fifth over x becomes x to the fourth, and then you still have this y to the sixth. So negative 10 x to the fourth y to the sixth. Plus, negative 108 divided by negative 9 would be positive 12, right? So plus 12. X squared over x becomes x to the first, and then you still have the y cubed also in the numerator, so positive 12 xy cubed. And then plus, again, a negative divided by a negative is positive, and this would be 9 goes into 126 14 times, right? 90 plus 36, 126. So that's positive 14, and then just the x's cancel, so this is positive 14 at the end. And there we go. And none of these terms are like terms, so I can't combine anything. That's it. Very simple, in my opinion, this assignment. So we have negative 10 x to the fourth y to the sixth for the first term, plus 12 xy cubed for the second term, and then plus 14 for that third term. And that should be good. Great. Alright, and based on my progress, I should have just one more of these. It's usually 4 questions or so per objective. Yeah, so here's one finally where there's just two terms in the numerator, a binomial, but divided by a monomial, right? So I'm going to split this up into the sum of two fractions, where each term in the numerator is getting divided by this expression in the denominator. Right? In fact, I'll just do this on the same page here. We've got plenty of space. So the first term in the numerator is negative 120 times m to the fourth times n to the sixth. And that's going to be divided by 8m squared n squared. Plus, and then the second term in the numerator It's negative 32 m squared n cubed divided by that same denominator, that same monomial 8m squared n squared. Okay, so first term here, first fraction, simplified, negative 120 divided by 8 is negative 15. 8 times 15 is 120. M to the fourth over m squared becomes m squared. N to the sixth over n squared becomes n to the fourth. So negative 15 m squared n to the fourth for the first term. Plus, and then a negative divided by a positive is negative, so I'll make this minus, and 32 divided by 8 is 4. So negative 4 for the coefficient, and then the m squareds will become m to the 0, or just 1. Those will cancel. Then n cubed divided by n squared is n to the first. So I'm just left with negative 4n for the second term there. And there we go. There's the result of dividing that binomial by that monomial. So first term, negative 15 m squared n to the fourth, and then the next term minus 4 n, right, minus 4n. Great. Alright, so again, hopefully it's simple enough. When you take a polynomial, something with multiple terms in the numerator, you can split it up to a sum of fractions where each term in the numerator is divided by the denominator, right, that common denominator. And then, of course, simplify afterwards. And that should be it for this preview version of this assignment. Now, like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment on your own. But the objective is the same. The structure should be similar. So I'm hoping that watching me do these here helps you out in some way when you work on the assignment on your own. And thank you very much for watching.